Hi and Assalamualaikum. We are from AP 246 3A Group 2 would like to present about the drainage system. At the end of the slide, you will know about what actually the drainage system, types of drainage system, which is surface drainage and subsurface drainage, the construction method for surface drainage L-shape, and what actually MSMA and SUDS. Let's start with the introduction.
Do you know what is drainage system? At my right side of my slide, I have shown you what is actually drainage system. Drainage system is a piping within a private or a public premises which conveys sewage, rainwater and other liquid waste to a point of disposal. Before we go through all about the drainage system, do you actually know what is the difference between the sewage and the effluent? A sewage is actually a suspension of water and solid waste transported by the sewer to be disposed or to be processed, while effluent is a stream that flows out, such as from a lake or reservoir or even an outflow. Do you know in building drainage term there are three forms of effluent? Number one is subsoil water. Subsoil water is a water collected by means of a special drains from the earth primarily to lower the water table level. It no need to be treated. Second is a surface water. Surface water is a effluent that collected from the surface such as roof and a path area. And lastly is fall or soil water. Soil water is effluent that contaminated by domestic or trade waste that require a treatment. We have two types of drainage. Firstly is surface drainage. Second is subsurface drainage. Let's continue with an explanation of surface drainage.
Surface drainage is very useful in removing excess water from land in a controlled manner and as quickly as possible to an artificial drainage system or a natural watercourse. This should be done with no damage to the environment. This is normally accomplished by shallow ditches, also called open drains. Shallow ditches discharge into larger and deeper collector drains. In order to facilitate the flow of excess water toward the drains, the field is given an artificial slope by means of land grading. What is open drain? These drains collect more silt and rubbish than pipes and allow increased residency of water to break down pollutants. Open drains can receive overland flow and thus have the advantage of serving as surface drainage. The size of open drains depend on the amount of water to be removed and formulas are available to calculate design parameters. As you can see here, this is a L shape. It's allow for quick and easy installation in open channel drain.
Subsurface drain is related to discharge seeping water through or contained below groundwater. This water usually occurs when the soil subsurface has a high moisture content. High humidity on the ground will be absorbed below the surface by gravitational pull. So there are two ways water can be absorbed by underground. First, gravity flow. Water from surrounding area can be absorbed by the soil, then flow by gravity to area under earth to pavement structure. In pavement structure with a height above 8 to 9%, water can be percolated down through the pavement structure itself. We know the water move through gravity. Capillary rush is the rush in the liquid above the level of zero pressure due to a net upward force produced by the attraction of the water molecule to a solid. In general, the smaller the soil grain size, the greater the potential for capillary rush. Often, capillary rush is a problem in the area of the high groundwater table.
So, we move to the next slide, which is the method of construction precast concrete drainage. So first of all, we need to excavate. Excavate for trenches to the required level. Second, foundation concrete. This is to prepare the surface before laying the precast concrete drainage. Third one is pouring, leveling and compacting the mortar. This is to make sure the precast are stable enough and can connect to the edge of the precast concrete drainage. Then install the precast concrete drainage. After that, we need to connect by jointing with the bolt of the precast concrete and make sure fill up the gap with the mortar. And lastly, backfilling. We use the excavate material and compact it until it's done. So, above my video is the design criteria and beside me is the material specification that have been used in many precast concrete drainage installation. And for information, that is the diagram of the precast concrete drainage.
So now we move on to the next one, which is MSME. MSME stands for Urban Stormwater Management Manual for Malaysia. It is actually a drainage design guideline which published by Department of Irrigation and Drainage Malaysia. The main goal of this manual is to provide an easy guidance for all regulators, planners and designers who are involved in stormwater management implementation. MSME is actually introduced on 1975 and is improved on 2000 and 2012 for first edition and second edition of this manual. Why do we need MSME? Malaysia needs MSME for urbanization, which is landscape change. As we can see on the slide, we can see the difference and the changes between Jalan Bukit Bintang in 1970 and 2019. The next one is for water pollution, water scarcity and increasing number of flash flood location.
Who are responsible to introduce stormwater management? Department of Irrigation and Drainage is taking proactive step by introducing new urban drainage manual known as Storm Management Manual for Malaysia, which states have been using implementing of MSMA. States have been using implementing of MSMA is Desa Pak Siti Kuala Lumpur, Senawang Negeri Sembilan, Metropolitan Point, Kuala Lumpur and so on. How does stormwater management work? Main purpose of stormwater management is detaining stormwater and removing pollutant. They are the impervious surface. Water will flow into the sewage and drainage system. Stormwater is used to maintain natural hydrology.
Now, we are going to discuss about SUDS. What is SUDS? SUDS stands for Sustainable Drainage Systems and also known as Sustainable Urban Drainage System. These systems are a collection of water management practices that aim to align modern drainage system with natural water process. Next, we are going to look why SUDS is important. SUDS is important because it is part of our green infrastructures. SUDS may minimize water runoff and flood risk in an environmentally friendly way by mimicking natural water systems such as ponds and basins.
Did you know the first sustainable drainage system to utilize a full management train, including source control in the UK, was the Oxford Services Motorway Station designed by SUDS specialist Robert Bray Associates. But how about Malaysia, where the SUDS is being used in Malaysia? Floods and flash floods can cause a significant impact to the performance and economy of Iskandar, Malaysia, an economic region located at Johor. Hence, Iskandar, Malaysia built a reliable, efficient and sustainable drainage system and stormwater management that can prevent floods or associated problems which may hinder the development.
So, how SUDS work? SUDS aim to mimic natural drainage by adapting techniques to deal with surface water runoff locally through collection, storage and cleaning before allowing it to be released slowly back to the environment. So, what is benefits of having SUDS? One of these is reducing flooding, enhancing water quality, reducing pollution, and also lastly, providing habitats for wildlife.
The choice usually comes down to whether the drain will be permanent or constructed at the site. This will depend upon the type of land and how high the budget is. Some of the most common types of drainage control system are used for drain water surface from their housing lawn. A proper drainage control can help prevent the worsening effect of water drainage. Lastly, Both residential and commercial buildings are often equipped with some types of drainage system.
That's all from us. Thank you and Assalamualaikum.